Hey folks, so in this video, I'm gonna continue the work on Azure clusters, like Azure Management and Workload Cluster tests for TCE clusters. So I actually had some ideas. I'm gonna actually share my screen and just talk about them. So of course, like I was thinking about this Azure Golang based end-to-end test. So I'm writing Golang tests. Previously, we had written tests using Bash, and we want to move to Golang now. So this is the code for the Azure test Azure deploy management and workload cluster end-to-end test. So and this is written in Bash. We want to move to Golang for like various reasons, for better control, for better error handling, and for lesser human errors. Like it's easier to actually miss out errors and problems in Bash and find out later that it's a problem. In Golang, it's more easier. You usually have some error being returned by whatever library that they're calling. And whenever we are going to define libraries, we'll ensure that we return errors. So yeah, I wanted to talk about like Golang based end-to-end test. Continue from my previous thing. So there is actually an existing end-to-end test framework in TC, and there are some upstream frameworks. So I want to do a video on checking out the existing end-to-end test framework and so this is done by two people, Shweta, Vladimir, and I think there are some more people who would have contributed to the upstream ones. And basically I wanted to take inspiration from it, probably copy paste from code from it, or just get its ideas, pros and cons, ensure that we get the pros, best of both worlds, what are we bringing new and the existing stuff that they have in the existing code. Because doing rewrites is pretty heavy and is time taking, is a lot of effort. But I'm trying to look at this whole test from a new set of eyes and in a bit of a different angle, which is different from the existing end-to-end test. But we will actually try to dig into that a bit now and think about the requirements to satisfy. For example, while writing this test, I want to think about some requirements. For example, providing libraries and functions like methods or functions to run clusters, delete clusters, and things like that, and helper utils to ease things. Like doing actions, get forwards, etc. And then verifying things, check if cluster is accessible, etc. And also for Azure, AWS, and vSphere, we're going to have like a lot of secrets. Like these are all secrets, like client ID secret key. This is a public key, but still we can keep it like a secret, like and hidden instead of like exposing it. And subscription ID and tenant ID are also pretty sensitive. So these are all secrets. And I was thinking about how, so if we provide it as a library, how would someone actually provide the secret from outside to inject it? So instead of getting it as environment variables, like for the library, so this is not the library, this is just a test, and we will create a library separately. And for the library, we have to inject these secrets. So for this test, we will pick it up from the environment variables. For the libraries, we'll inject the secrets through arguments. Instead of inferring from environment variables, I want to like provide helpers to extract secrets from environment variables. For example, extract secrets from these to create some say struct or something like that, and then pass it on to the library function, so that whoever is going to use the binary created from the library can actually run the binary with some environment variables, and then that binary will actually have some helper functions used to actually extract that environment variables and then convert it into some struct or something, basically some sort of config thing, secrets thing in this case, and then send it, like inject it into the functions, methods, or wherever we need it, and send it into the libraries, methods, which are going to create clusters, delete clusters, or do whatever. And we need to have metadata about these environment variables to show good error messages, because For example, I say Azure client ID to understand. Let's say I'm saying it's not available, then it's easier to give some extra information. But for now, I'm not going to do it. But it would be nice to actually just give some extra information saying, hey, when I say Azure client ID, I mean this exact thing. Point it to some Azure docs and then point it some Tanzu Community Edition docs and let's say, hey, this is how you can get it, so that the user can actually do some action item. And this is something that I tried out recently on ENV was missing, try it out, run the test, and then try out running the test with all ENV was present. And then with some, this I didn't try. I'm going to try out now. Let me actually do go test -v./. So it says environment variable Azure client ID and then client secret, public thing, whatnot, right? So now let's actually add all of them and let's run. It's all good. So this one has dummy variables. Now I'm going to actually unset some of them. Let's say I unset this alone, and this is not available. So now I actually do go test and then so it says is not available. And let's unset one more maybe. Say client ID. Okay, cool. So echo Azure client ID. So let's run this. And it says client ID and tenant ID. Cool. So yeah, even if some of them are missing, it works. And then if all of them come back, it will be good. So it gives proper errors. So all of this is good. And we show good errors. Yeah, I mean, it's good enough. And so yeah, now let's go and check out this end-to-end test framework that I was talking about. So the end-to-end test framework is here. And so this is based on Ginkgo, I think. Anyway, let's check this out. So this is the end-to-end test, the whole directory. And it has some, it has a README. So let me probably preview this. Yeah. So this is the folder in which we can invoke end-to-end test for TCE add-ons packages. Dependent packages or tools like YTT would be handled with respect to add-ons package suits. Okay. Support flags, kubeconfig so to set the kubeconfig file path. Okay. Kubecontext to set the cluster context. Packages, which packages you want to filter out. So in case of Golang, I think since we are writing Go based tests like Golang standard library, standard library, like standard testing library that Golang provides, since we're using that, Golang actually provides a way to actually run some set of tests given a regex. So in this case, instead of providing this flag, we can also probably use the regex and say, run these packages alone or something like that, or have some config file and then pick up things like that, or still provides a flag similar to this. And then version of the packages. So it's a bit weird, this thing though. We say which package and then which version. So respective. So if we say package A, comma package B, comma package C, and then in version you have to say package A version, comma package B version, comma package C version. That's a bit weird. So I think a better way would be just to provide package and then version number together, so that it's like it's a single unit. Given a package, you mention the version of the package that you want to like test. So package colon version or something like that, or package hyphen version, something like that. And that's one idea. And then the cluster type. So management cluster, worker cluster. Previously, we also had a standalone cluster, and then now we do have unmanaged cluster, and probably in the future we might have different kinds. I'm assuming for now there won't be with that. And create the cluster, provide true if cluster has to provision, provide false if the cluster already exists, and if true, automation creates cluster based on the provider and cluster type. Okay, so I think the whole idea of this end-to-end test framework is like to, if you want to create the cluster, sure, go ahead, create the cluster, and then run package tests, and then finally just come out. It just doesn't delete the cluster, I believe. So and you can also provide a particular TCE release version to install. So it says if not provided, then build it from source code. So make release, return that. And guest cluster name. So this is for the workload cluster. In the case of managed cluster is being run. There's also provider being mentioned here. So Docker, AWS, vSphere, and all. And then there is a management cluster name, and then this cluster plan like dev prod, and then cleanup cluster. So there is also actually Terraform cluster. So if you mention that, it will be toned down. So how to run framework to install TCE release from GitHub page, provision cluster, and test. Ginkgo-v kubeconfig, kubeconfig file, and then external DNS package. You run the test for that, and then 0.8.0 Docker, and then management cluster, TCE my cluster, and then create the cluster, and then TCE this 0.7. Yeah. So it's pretty interesting actually. You have a lot of knobs to actually turn up and down, and it's pretty cool. How to run this, building from this, so okay, cool, create a cluster. And if you say all, this runs for all. And add-ons test. If the cluster is already available, then you say, you don't say create cluster and that's it. It just uses the existing cluster and how to pass the cluster context and things like that. Awesome. And the context is usually based on like username at cluster name. So user name, yeah, the name of the user and then the cluster in between that. That's how TC generally or like Tanzu generally creates the context name, since context is a mix of the user or the like auth and the cluster. Put together, you actually sign into a cluster as one identity. So notes, if all the packages package test needs to run, then version is not required along with package is all. By default, package all will run the package system for the latest version of respective package. One can modify the required package version also if they wanted to test lower version of support packages. I think this is pretty cool. You can learn a lot from this. It's pretty straightforward. Let's check out the code. So this one has the end-to-end test code. So this is describe end-to-end tests, smooth testing in progress. And that's the only thing. So validate Tanzu CLI. So check package repository list all namespaces. Okay, so where is this? Yeah, so this is here, package plugin package repository list -a, so all namespaces list all the repositories. Error shouldn't have occurred, so Tanzu CLI basically checking a package plugin works with other generally like yeah, package plugin. Package available list and then package install list. So package available list all namespaces and then available list and then list all namespaces. Awesome. And I think this is pretty cool. And I think this is coming from the Tanzu people. And we go to say next thing, run add-on package test, run add-on tests, and then delete the cluster, and then that's it. Cool. So run add-on tests. So the code is over here. So it says install metal LB in case of provided Docker. So in case of Docker, you have to have some different kinds of packages, extra packages to actually make some things work. For example, load balancer, you will need metal LB to work, make it work on Docker. Unlike let's say it's AWS Azure, where you will have load balancer and you'll get public IPs and you'll get private IPs and all that. And they have some controllers to actually take care of that. Whenever you say the Kubernetes service type is load balancer, but in this case of Docker, you need to actually install MetalLib and configure it. So they're doing that. And so this is a bit of a mix, but yeah, this packages. So it checks all the packages and versions, and then if it's all, this run all package tests. If it's only some of them, then run only those package tests based on the list of packages. What else? So it does run package test, package name. Awesome. So it goes to that particular package name, and then it just runs make end-to-end tests inside that directory. And what else? Okay, there are many like get resource object, run add-on tests. We are done with that. Initialize. So there is an install TCE thing. where you can install TCE. Let's see where that is. So it says Tanzu is already, so it checks if Tanzu is already there and then start building a TCE release, like, in this case, it tries to do download or build TCE. Like in this case, it tries to actually download the daily build or build TCE from scratch from like make release. And and there's also this thing where you can actually see that if there's no TC version provided, that's what they do. But if there's a TC version provided, they actually fetch that particular version of TC using fetch TC. And yeah, so this is a particular shell script. I think this can all be like Golang, so that it's more, we have more control and it's more easier to understand things instead of like we run around different shell scripts. And there is some interesting stuff around like package config where they check out package configuration, they like parse the YAML, and so this is Go package YAML version 2. So they parse the YAML and then get the names and versions and then use that to actually I think run the tests. So add-ons config is this. I think this is present globally. This is a global thing, and that's being used to run all the package tests. And finally, we actually delete the cluster. Let's look at what's that. So there is delete cluster over here. So you can see we just do depending on the cluster type, right? So and the kind of cluster. So if it's Docker, you do this. If it's managed this, and things like that. So if it's a managed cluster, then I think the workload cluster is deleted, or it's like a first workload cluster is deleted and then managed cluster is deleted. And it's like they don't have an information for others, but that's okay. Validate all deployments are ready. This is happening in the check cluster health. A lot of interesting stuff like create management cluster, check the cluster health, and then get the queue config and things like that. Interesting. So it checks if, so it uses Gomera and then it checks eventually with offset, and it checks if you can get all the deployments, and then takes the statuses, the condition, checks if it's available, and then status. So all of them should be true. It should not contain false. So eventually at least. And the same thing with deployment ready, some particular deployment ready. So given a namespace and name, in that particular namespace and name, so they are looking for that particular thing. Deployment was never ready, and they are giving errors or they are here. I think they could have given an extra error saying not all deployments are ready. Maybe some are not ready. Um, Cool. And cluster health, let's check it out. So the cluster. So cluster health, they get the context. What is this? Conf is actually coming from this client. So this is actually the end-to-end test framework. So we get it here. End-to-end test framework is here. And you can actually see this. This is created from a template project, and they have a lot of comments here. And it has been contributed by many people. Looks like, I mean, I primarily know that Shweta and Vladimir worked on this. Two folks in VMware in Tanzu team. Let me try to. This is still loading. It's very slow. Right, it's pretty slow. I'm just gonna open up a new tab for now. And so this is Shweta, and like she developed a lot of this, and Vladimir. And then there were other folks also, as you can see. And Yeah, so if you look at the thing, Go framework for end-to-end testing of components running in Kubernetes clusters, the primary goal of this is to provide a Go testable framework that uses the native Go testing API to define end-to-end test suites that can be used to test Kubernetes components. Our additional goals include provide a sustainable programmatic API to compose tests, leverage Go's testing API to compose test suites, expose packages that are easy to programmatically consume, collection of helper functions that have sets, client Go functionalities, rely on built-in Go test features to easily select a filter tests. So I think these are some interesting stuff. This is something that even we want, and rely on built-in Go test features to easily select a filter test. So this is also something that I've been also thinking about, like using regex and things like that. So yeah, to run execution, to run tests to run during execution and more, and like there's also a design document, pretty interesting. I'll go check this out. The Go package is designed to be integrated directly in your test. Simply update your project to fill the desired Golang modules. There is client, there is package, and then set up the test main, and then find cluster, random name, and then random name. Redefine environment functions to create a time cluster prior to test run. Set up in a create time cluster, and then use it to bear down, finish, delete namespace, launch package tests. Then, define a test function, features new count pod with label. Okay, that's in Dart. Okay. Features new count pod with label type pod count assess pods from queue system, and then context, and then config client resources queue system list to do pods, and then zero no pods return context. Feature. Just wondering what this is about. Like count pods, it counts the number of pods, I think, and returns that as context. Returns the context, but weird that it doesn't count it. Uh, test features, the count namespaces. And if it's zero, we give error, or else it's all good. Some pods are there. Same thing for namespaces. You check if there is like at least more than one. So, and you skip labels, types, ns count, args, skip labels. Okay, what's that? Use a good estimate to run the test in a application here. Following would run only except those with label type ns count. Oh, so this is that label. I guess this is what it skips. I don't know. See the examples, and then there's skip testing, and then there's minimized. Cool. That's pretty interesting. I'll go check out this design doc, and I could check out the code. That would be very interesting. For now, I'm just going to go ahead and check what they do though. They say new with context name, resolve the cube config file, and then context name, they give the context. So they use those good stuff. I think we could use this as long as like it's all good. If it's not good enough, we can just ask them just to provide something better if we think it's not good enough. But I'm yet to look at this. And as of now, I don't have Go enabled in this directory, so I'm just not going to look at it for now. But I could actually open this up in one. So this does not have a Go.sum or Go.NET file. Interesting. But yeah, if I open up this directory only and then go in a workspace and then enable Go, it should all be good. But there's no Go.sum. So I'm just wondering why it's the case. Anyways, we'll figure it out. And validate all. Then okay, delete cluster. Cool. So I think it's mostly straightforward, pretty simple. But why I wouldn't use it directly now is, I mean, of course it works. I mean, I've seen it work, and I'm gonna try it out soon too. But I still wanna look at this with new set of eyes, and then look at how we can do things, and like provide secrets, do stuff, and like also do everything in like Golang and stuff using scripts. For example, use AWS Nuke, AWS Nuke client library, AWS SDK Go, and Golang SDK also. Golang is Golang client library, sorry, or Azure Golang client library, and then things like that. Right? So I don't think these use them yet. Instead, I think the tear down is still dependent on things like, say, I mean, if there is an issue in tear down, we still don't do any other cleanup over here. Or we could say that it is not the responsibility of the endpoint test to do a cleanup. If a tear down fails, something else can take care of it. We could also go with that way. Then this would all be good, and we can take care of any issues that happen and go ahead and like fix them. Like, say, have some other service to take care of, like when deletions don't happen properly, or things like that, or some failure happen in between the creation, like in midway during creation, and create didn't succeed properly, so delete also cannot work properly. Then we still use some external service to delete things. So yeah, that's that. And so currently, where are we? So I actually wanted to install Tanzu framework or TCE using pre-built tarballs, using some utilities. I might do that, and then check out these, and then come here wherein create random names, hard code stuff, and then probably start using Azure Golang SDK, Golang client library basically, and try out logging in and accepting the VM image license or terms, and see how that goes, and maybe even do a dry run instead of like hard coding these values. But yeah, first start with hard coding, and then you know maybe do the management cluster or workload cluster dry run to get Azure or like Azure VM image names or SKUs, and then offering, and what else? There is also this thing called the image publisher, right? So publisher and this. So yeah, I'm gonna pause now and then get back to this, and have another video where I do this. And I think this is going to be pretty interesting because like once we get this done, we can actually have more control over the endpoint tests, over the errors, and have exact information, more information, and be able to collect more information, statistics, and whatnot. Instead of, and we'll also be installing lesser tools like Azure client, like if we use Azure client library, AWS client library, AWS new client library, and things like that, we will not have to install those tools at all. AWS CLI or Azure CLI or whatever, or AWS new CLI or kubectl or Docker CLI and things like that. But of course, kubectl and Docker are needed by Tanzu, but we will not actually depend on it, and it will still work. Cool. And I will stop this video, and I'll see you in the next one. Bye bye.